equations involving composition functions. On the first 2 pages here, if you want to pause the recording so you can write it down. This here, I thought that would be helpful if I put it all in step-by-steps with some instructions. This will help you maybe on certain questions. Because whenever we lecture and go over this and you're taking notes and you go back to read your notes, it might not be as easy to understand. So I'm hoping that might be some help to you. Let's start off this first equation here. It says find all real numbers that satisfy this equation of cosine 2x equals 1. So to start off, I need to find its inverse. And when I do that, I get 2x is equal to cosine inverse 1, which we know cosine inverse 1 is equal to 0. So knowing that it is equal to 0, we're going to plug it into this formula of 2x is equal to my pi plus, or not my pi, my s. My apologies, guys. (2k pi). And what did I get for s? I got 0. And now I have 2x. And you can leave the 0 there or take it away. I'm going to just drop the 0 off. I'm going to divide by 2 on each side to get x. And now I got x is equal to k pi. So this would be the formula that I use to find all points. Where did I get this from? Y'all remember at the beginning of this chapter, I gave you a set of formulas. And it said when a was equal to 1, we're going to use this specific formula. And this is a is equal to 1. Okay. Let's do example 2. Find all real numbers that satisfy the equation of 2 sine x halves plus square root of 2 equals 0. So we got some work to do here before we can get any further with this. So what I want to do is go ahead and say, oh, let's subtract the square root of 2 by both sides. That gives me 2 sine of x halves is equal to negative square root of 2. Then I'm going to divide by this 2. So now what I have sine of x halves is equal to a negative square root of 2, right? So far, so good. All right, so looking at this, we know that my a is not 1, it's not negative 1, it's not 0, it's not greater than 1. However, we need to figure out what, when we solve for the inverse, so let's solve for the inverse, what s is. And when we do that, now we're going to get, let's do sine inverse, and make sure we're in radians. So I'm going to check to make sure I'm in radians. Negative square root of 2 halves. So that's going to give me a negative half force. Okay, so now that I have that, we can figure out on the unit circle where that specific spot is. It would give us s is equal to, so if I go to the unit circle at a negative pi halves, I get a value of 5 pi fourths. I typed it in the calculator and I get a negative pi fourths, okay, because I took the inverse of it. So let's try one thing before we go any further. Yeah, so make sure that we're in, let's see, negative square root of 2 over 2. Yeah, you're going to get, but anyways, so from the unit circle, I get 5 pi fourths. We know we start off with a negative pi fourths. So knowing this, we're going to figure out our next set of points. I'm going to say that this is my smallest value on the unit circle. All right. So knowing this, I have S is equal to all of this, right? We done declared that. And again, I want to say that 5 pi force is my smallest. So we're going to find all real points. And so if I go on there, I also notice that I get 7 pi force along with that pi force, right? So I just, and these are the what I can pull off the unit circle. We know that we want to look from 0 to 2 pi. So that means we're wanting to do a complete circle around the unit circle. So let's solve for this. Looking at this, S is less than 0 because it's negative, right? So my S is less than 0. That means we're going to use the formula of a set of X that builds on when X is equal to S plus 2 pi plus 2k pi, or X is equal to pi minus S plus 2k pi. So what I want to do is I'm going to pick my my smallest 5 pi force. You can pick the negative pi force too, because all these points fit on there, but I would pick the positive value of it. However, I want to start with the 5 pi force. So I got 5 pi force plus the 2 pi plus 2k pi. I'm not plugging in for k, so we're only going to combine the 5 pi force plus 2 pi. And when I put those together, I know that it's a fraction. I got a common denominator of 4. So now I got 5 pi plus 8 pi over 4 plus 2k pi. And that gives me what? Oh, my apologies, guys. No, that's right. Make sure and follow the formula. Sometimes it might have looked at it as a positive value. If that was a positive value, we would have used just the S plus the 2k pi. Okay, so just make sure and watch for that. So, oh, and don't forget our 2 goes on the outside because that was what was up here, and it's divided by 2 9 times. So let me get my stuff together. Okay, so what I'm going to do is just, my apologies, guys. All right, here we go. I got X house. Okay, so we have 5 plus 8. That gives me 13 pi. And let's get my computer back on track. Well, my apologies, guys. The computer decides, there it goes, maybe. So it's 13 pi force. Hmm. So I'm going to go ahead and plug in the negative pi force first. So I clean this up. It's a little bit of a mess. Where to go? So to do that, we know that we need to have a common denominator, and it's going to be 4. So now I got negative pi plus 4 pi over 4, or excuse me, 8 pi. My apologies, guys. Which gives me what? It gives me 7 pi force plus 2k pi. And now we need to undo this fraction over here. So we're going to multiply each part by the 2. So now I have x is equal to, and these 2 and that 4 reduces. So I got 7 pi halves plus 2k pi. Also, I wanted to try, before I come over and do this other side, I wanted to try plugging in 5 pi force, because we know it's on the unit circle as well for this particular point. And so I'm not focused on this one here yet, okay? Let's just take that x halves, plug in the 5 pi force, add it to the 2 pi plus the 2k pi. And then we gotta have a common denominator. So now I have 5 pi plus 8 pi over 4 plus 2k pi. Oops. So let's go back to question 2. Okay. Let's rewrite it. Two pi. My apologies. My computer is acting up. All right. Now 13 pi force plus 2k pi. We got x over 2, so we're going to multiply each side by 2 to undo this fraction. So now I have 13 pi halves plus 2k, or plus 4. I don't want to try plus 4k pi. So I apologize for the messiness. I usually would erase, but the computer is just not wanting to cooperate again. So, all right. So we got our small values here going on. Let's find this other side, the OR part. So the OR part says we got pi minus that is. Okay. So I have x is equal, or x halves is equal to pi minus, we can say that negative pi force plus 2k pi. We can figure out when x half is equal pi minus that 5 pi force plus 2k pi. And the solve, the negative times the negative is positive. So I have pi plus that pi force plus 2k pi. And then let's see if my screen will let me scroll down just a little bit. Yeah. We gotta have a common denominator, which is 4. So now I have 5 pi force, 2k pi. That worked out great, didn't it? It gave us back that 5 pi force we found on the unit circle. And then over here we have equal to pi minus that 5 pi force. Again, we're going to find common denominator. So that's going to give me a negative pi force plus 2k pi. Oh, and guys, we still got to multiply this side by 2, right? So now I get x is equal to 5 pi halves plus 4 pi, or k pi. Oh, we saw that up there somewhere. So now we're going to end up with 4 possibilities. And this one here is negative pi fourths plus 2k pi, multiply each side by 2 because we got to undo the fraction. Now we get x is equal to negative half pi halves plus 4k pi. Now this would have turned out nice and prettier and easier if the original equation would have been a positive value for s. You know, it's okay. Just watch which equation that you really need to use. Okay. Now we are on example 3. Example 3 says find all values, find all the real numbers that satisfy the equation of 2 sine x halves minus 1 is equal to 0. So that was the one we just did. My apologies. My computer has... No. Okay. We're good, guys. With you. So what we're going to do is we're going to add this 1 to both sides. So now I got 2 sine half or x halves is equal to positive 1. We're going to divide by the 2. Now I have sine of x halves is equal to a half. So a is not 1, 0, negative 1, and it's not larger than 1. So we're good with that. Let's figure out what x is, which is s. Right? We want to know what that is. So we have to take the inverse. Now, sine inverse of a half, well, if you plug it in, we get sine inverse of a half. We get pi 6. So s is greater than 0. So we are going to use that set that builds on x, where x is equal to s plus 2k pi. And now you see why I said it would have been easier, because we didn't have an extra step in here. And x is equal to pi minus s plus 2k pi. All right. We know that a half is not equal to 0, so we're good. We do know that the pi 6 is falling between negative 1 and 1. We are good with that. We know that we have solutions on the unit circle. We just found one, which is pi 6. Also, when you go to the unit circle and you find a half for the sine, we also see that it falls at 5 pi 6. So I want to use that, these particular ones, to calculate my answers or my formulas. So knowing this, I'm going to use these formulas. I'm going to say, and I got in the place of x, I got to put x halves because that's what we got up there, right? And that's equal to my s. Well, I'm going to do pi 6 for the starter plus the 2k pi. Now, to undo this fraction, we know we're going to multiply all parts by that 2. So that 2 and 6 reduces and leaves me with x equals pi thirds. That 2 times 2 gives me 4k pi. Now, let's take this one over here and solve for it again. So we're going to have a total of 4, okay? So I got x halves. I need to put a box around this. Oops. Is equal to 5 pi 6 plus 2k pi. We're going to undo the fraction. So now I got x is equal to, and that 6 and 2 reduces, 5 pi thirds plus 4k pi. All right, very good. Now let's look at this part. So I'm going to scroll down just a little bit. So looking at that part there, my apologies about the mess on the screen. We're going to plug in those values again. So I'm going to take my, if you need to split it, x is equal to pi minus s plus 2k pi. Let's plug in the pi 6. And don't forget, it's x over 2. And it's going to be pi minus that. My apologies. Here, let me get my eraser to work. So it might take a minute. I'm give the computer a second to catch up. Okay, let's come back. All right, let's see if it's going to erase. Hmm. Hmm. Okay, so now let's plug in. So we got pi minus the pi 6 plus 2k pi. So we're subtracting a fraction, so we need common denominator. So I have 6 pi minus pi over 6 plus 2k pi, which gives me 5 pi 6 plus 2k pi. It's equal to x halves. We're going to multiply each part by 2 to undo the fraction. So I have x is equal to, and these 6 and 2 reduces, leaves me a 5 pi thirds plus 4k pi. We already have that one up there, so we don't need to write it twice, okay? So you notice you got it up there, very good. Now let's take the x halves equals what was our other one? My apologies, guys. Let's look at it. Let me scroll up. 5 pi 6. Let's plug in 5 pi 6. We got pi minus that 5 pi 6 plus 2k pi. All right. It's a terrible looking pi. There we go. We are going to subtract, so we need common denominator. So I have 6 pi minus 5 pi 6 plus 2k pi And this gives me x halves equals pi 6 plus 2k pi. Now I'm going to multiply all parts by 2 to undo the fraction. So now I have x is equal to, and the 2 and 6 reduces, leaves me a pi thirds plus 4k pi. And again, look, it worked out great. We came up with it. So we're only going to have 2 values. Sometimes you're going to have more, okay? So that's all the work we need to do. So we only need to list those 2 values once a piece. Okay, so let's do example 4. Example 4 says find all the values of x in the interval of 0 degrees. And if you notice, the 0 degrees has the bracket, so it means it can equal 0. And it goes up to 360, but it does not include 360 because it has this parenthesis on it that satisfies this equation. So I'm going to do the work that we always do. We're going to get it to where we got the sign of the x value on one side. So let's subtract the 1 because it's positive. So I got 2 sine of 2x equals -1, divide by 2. We want a coefficient of positive 1 on sine. So this is what we got left. Okay, so we have a value of a -1/2. So it's not any of the values of when it says that if it falls, if a is 1, -1, 0, or greater than 1. So those resolved all those issues. Let's move on to the next part. Let's find its inverse. So we got 2x is equal to sine inverse of -1/2. I'm going to plug that in my calculator to get that value, which I know it based upon the unit circle. If I was to just tell you on the unit circle, it is. And remember, we're working in degrees modes. So it should be a -30. I'm just going to double check. And I get in radians, I get a -pi 6, which is in degrees mode. So make sure y'all are in degrees mode since we are working with degrees. It's -30 degrees. Yes, good deal. So, I mean, knowing the unit circle will help a lot here too as well. So what we're going to do is that we know it's 0 to 360. And if you need to draw it out, I would. You got 0, 180, 360 here. So I am going to take this -30 degrees and I'm going to say 180 degrees minus that 30. Well, that gives me 150 degrees. So gives me one value. What if I said 180 degrees minus the -30 degrees? Well, that's going to give me 210 degrees. If I said 360 degrees minus that 30 degrees, that's going to give me 330 degrees. I'm not going to add it because I don't want to go over 336. So I know I got a value of 210 and 330 that we're going to work with, okay? And since the S value is less than, we are going to use 2x is equal to my degrees, which will start with a 210. We're going to add it to the k of 360 degrees. I'm going to divide by 2 on both sides because I need x to be a +1 coefficient. So now I got 210 divided by 2 is 105 degrees. And that 360 divided by 2 is 180 degrees. All right. So this one was at 210. Let's do the one at 310 or 330. So I got 2x is equal to 330 degrees plus that k of 360 degrees. We're going to have to divide by 2, right, on both sides. Give my word a second to catch up with us. All right. Gives me x is equal, and half of that 330 is 165 degrees. And then k of 180 degrees. Okay, now these are the 2 we want. Let's start finding out the values. So what I'm going to do is I'm going to let k be some point. And if you need to, let's just do this. Let's fix our screen. Oops. And let's say, okay, when K is 0, well, if I plug 0 in for K, I just get X at 105 degrees. When K is 1, well, now what do we get? We get X is equal to 105 degrees plus 1 times 180. So we're just going to add those together. So we got 105 is one value. So I'm going to take the 105 and add the 180, and we get 285 degrees. All right. Now, it may only ask for 4 values. If it asks for more than that, then you can do K is -1, K is equal to 2, K is equal to -2. So depending on how many they want, this one here is not asking for a whole lot. So just be sure and read what it asks for. Let's come over here and find when K is equal to 0. I'm going to plug in 0. Well, X is equal to 165 degrees. Let's plug in when K is equal to 1. We'll get X is equal to 165 degrees plus 1 in the place of K, 1 times 180. So I'm going to put a box around this one. So now we're going to say, okay, 165 plus that 180 gives me 345 degrees. So my sets are going to be 105 degrees, 165 degrees, 285 degrees, 345 degrees. Okay. Let's go to our example 5. We're going to find all values of alpha in the interval of 0 degrees, 360 degrees. You do see that the 0 degrees is equal to, or can be, and it's approaching 360. It's not going to equal it. We got cosecant of 3 alpha is equal to 2. What I know about cosecant, we know that cosecant is the inverse of sine, right? So if I was to write this in sine notation so we can not figure out which formula to use, then I know that it's sine, and I'm going to go ahead and put in alpha, and I'm going to put the 3 alpha there. It is going to be equal to 1 over the cosecant, and the cosecant is going to be what? 3 alpha equals to 2. Well, if I know that 3 alpha is equal, or cosecant 3 alpha is equal to 2, then that means I have sine of 3 alpha is equal to 1 over 2. Okay. Knowing that, because this here is saying that it is equal to 2. So we put 2 there. Okay. So now we know A is a half. So it's not equal to 1. It's not greater than 1. It's not -1. It's not 0. So now we need to figure out what is S. So let's find the inverse. So when I take the inverse of sine of a half, I get, and we are working in degrees. That's good. So I get 30 degrees. So this tells me that my S is greater than 0. So knowing that, we're going to use the formula of the set of X that builds on X equaling S plus K 360 degrees, or X equals 180 degrees minus S plus K 360 degrees. Okay, so we know that much. Now we need to finish solving for all this. So we're going to take that 3 alpha. I'm going to set it equal to, and let's plug in. Well, we said S is 30, so I'm going to plug in 30 degrees plus that K of 360 degrees. I got to divide by 3 because I need alpha by itself. So when I do that, now I get 10 degrees plus K of 120 degrees. And let's do this other side the same way. 3 alpha is equal to 180 degrees minus that 30 degrees plus the K of 360 degrees. 180 minus 30 is going to give me 150 degrees plus the K of 360. It's all equal to 3 alpha. Divide by 3. So now I got alpha is equal to 50 degrees plus that 120 degrees K. So now that I know that, I can start finding my exact values, right? Because I can plug in. And again, just read what it asks for if it wants however many values it wants. Okay, so in this particular one, we're going to solve for 6 values. And once my word is loaded, we're going to, I don't know why it did all that. So we have to, my apologies, guys. I'm definitely going to take my computer to IT. Let's get this fixed back again. So we need that information that we just had. Hopefully y'all wrote it down. Okay. And over here. Okay. All right. Good deal. Now, this is what I want. I want these formulas, and we're going to pick. And we're going to start off with, it's going to let me scroll down. I want to find when K is equal to 0. Well, plug in 0. We know alpha is equal. K is equal to 0. We know alpha is equal to 120, or excuse me, 10 degrees. My apologies. I'm just getting a little aggravated with this computer thing. So it's 10 degrees. When I'm plugging 0 for K, we get alpha is equal to 50 degrees. So now I got this value and I got this value. Now let's plug in for K when it's 1. That means alpha is equal to 10 degrees plus that 120, because 120 times 1, because K is 1 now, gives me 130 degrees. Okay, so let's plug in when K is equal to 1 here. Get alpha is equal to 50 degrees plus K is 1 times 120 degrees. That gives me 170 degrees. So that's my third. Let's plug in when K is equal to 2. Then that means I get alpha is equal to 10 degrees plus 2 times that 120 degrees. Well, 2 times that 120 degrees gives me what? 240 degrees. Add that on, we get 250 degrees. Now let's plug in when K is equal to 2. We get alpha is equal to 50 degrees plus 2 times that 120 degrees. That gives me 50 degrees plus 240 degrees. And that's a total of 290 degrees. So we got 6 values here. Give the computer a second to catch up. Okay, example 6, find all values of beta in the interval of 0 degrees to 360 degrees that satisfy the equation. Use the degrees measures. So we are working with cotangent. So let's talk about it a little bit. We do need to find its inverse, and we can rewrap this in a format that we understand. So if I said, when we're talking about cotangent, let's just do that for just a minute as a refresher. We know that that's 1 over tangent of that beta. We also know that that becomes cosine of beta over sine of beta. The step I skipped out, I'm going to go ahead and put it. It goes in between these two. It's actually 1 over sine divided by cosine, and then you flip it, right? Keep change flip. Okay. So now, let's get it in its inverse form. We also know that this here is also written as 1 over tangent inverse of that 1. Okay. So let's talk about when this appears at 1. If I was to say, when does tangent become, or when it that angle becomes 1 at that particular point? Well, we know that there is a point on the unit circle where sine is square root of 2 halves and cosine is a square root of 2 halves, where they're both at the same, right? Same exact values. Well, knowing that, then I can say, oh, okay, well, my cotangent of that negative, or the cotangent inverse of that 1, well, what does that give me? That says, okay, what if I said my cosine is square root of 2 halves and my sine is square root of 2 halves? So I went back here. Okay. So if I plug that in, what happens? Well, I got square root of 2 halves divided by square root of 2 halves. We're going to keep change flip. And when we do that, now we got square root of 2 halves times 2 square root of 2 halves. That gives me 1. What does that tell me about my degrees? It tells me that this is going to be at the beta of the cotangent inverse of 1 is going to be at a 45 degrees. Okay. Now, knowing that, I'm going to use what I know about the tangent formula. So I got beta of 3, and we're going to plug in our angle here, which is 45 degrees, or remember it was called S. And we're going to add it to K of 180 degrees, because remember it's pi, not 2 pi, because we are talking about tangent. And now let's solve for it. I got to undo the fraction by multiplying by 3. So let's multiply each part by 3. So now I have beta is equal to 45 times 3, which is 135 degrees, plus 3 times 180 degrees gives me K of 540 degrees. And that would be our answer here. If it wanted the numbers, you can plug in for K. I would choose 0, 1, 2, and then go to -1, -2 if it wanted more than 3 or 2. Okay, so find example 7, find all real values in the interval of 0 to 2 pi. Now we're in radians, okay? We're going to use this equation. We're going to find the values that satisfy it. So I need to get cosine by itself. So I'm going to add the square root of 3 to both sides since it's a subtraction. So now I got 2 cosine of 2x is equal to square root of 3. I'm going to divide by this 2. Now I got cosine of 2x is equal to square root of 3 halves. When again, we know that it's not larger than 1. It's not equal to 1, not -1, not 0. So we know that we got to go to where we determine if S is greater than 0 or less than 0. So let's find the inverse. So when we do this and find the inverse, well, let's take that inverse of cosine, and square root of 3 over 2. and it gives me, oh yeah, and put it in radians, which it's going to be pi 6. It's positive, so I know that my S is greater than that. I also know that when I go to my unit circle, I found that it's going to be, well, it's going to be, hang on, before I go any further, let's just keep solving this right quick. So now I'm going to take the 2x. Because S is greater than 0, I know that I'm going to plug in. So I'm going to take the pi 6. I'm going to add it to the 2k pi. I'm going to divide by 2 to undo this, right? So when I do this, I get x is equal. Well, I got pi 6 divided by 2, so I'm going to change it to multiplication and flip it. Add it to 2 times it, or 2 divided by 2, which is 1. And now this gives me pi 12ths. Okay, so now we know that value. Let's talk about another point on the unit circle. On the unit circle, I find that we also get pi 11ths 6 on the unit circle. So let's use it to find that value. I apologize, it's annoying. So let's see what we can do. We'll have to, let me just rewrite the answer right here real quick. I apologize. So now I have pi 12ths plus k pi. All right, we're good with that. We need this right here. So we're going to find the exact values. Now let's do the same thing here. Oops. And then we're going to divide by the 2. I went ahead and did that notation. We're dividing by the 2, right? So now I got x is equal to 11 pi 12ths plus k pi. And we need this one too. So now let's go find values when k is equal to 0 and k is equal to 1. Okay. So when I plug in 0 for k here, I get x is equal to pi 12ths. When I plug in 0 for k, I get x is equal to 11 pi 12ths. When I plug in when k is equal to 1, we have to do a little bit more work. So I got pi 12ths plus 1 times pi. So now I'm going to have to find a common denominator, which is 12. So now I have pi plus 12 pi, so I have 13 pi 12ths. So that's another value. So let's find our last one over here. Plug in 1. Then I got x is equal to 11 pi 12ths plus 1 times that k, which is 1 times pi. We got to find a common denominator. So I got 11 pi plus 12 pi, which is 23 pi 12ths. So we got 4 here. If it wants more, then I would use k equals 2. And if it wanted more than that, then I go to k equals -1. All right. Let's solve our next question. Our next one says, find all real numbers that in the interval of 0 to 2 pi that satisfy the following equation. So the equation is cotangent. So let's just get it written in the format of cotangent inverse. So I'm going to add that square root 3 to both sides. So I got cotangent of x half is equal to square root 3. Then I'm going to take its inverse. So I got x halves equal to cotangent inverse of square root 3. Now, again, we know that cotangent, right, is going to be 1 over that tangent. So knowing that, I need to figure out when we get values of a square root of 3 as our final answer. So one way to look at it is to go to the unit circle and find one of the exact order pairs, exact values that has a square root of 3 in the numerator of one of them, right? And then go from there. So I always start in the first quadrant. It's all going to give me positive values at the moment. So we'll start with that. And when I go to the first quadrant, I notice pi 6 gives me the order pair of square root of 3 halves, comma half. So I want to play with these numbers and see what happens. I know that this is 1 over sine divided by cosine, which is rewritten as cosine over sine. So knowing that, that means I would have the square root of 3 halves over the half. Remember, because it's cosine, sine in the order pair. So I'm going to rewrite this, and I'm going to apply the rules for fractions of keep, change, flip. So I got square root of 3 halves times that 2 over 1. What happens? The 2's reduced. I got square root of 3 over 1. So that is what I'm wanting to use. That tells me this is pi 6. All right. So I'm going to take this pi 6, and I'm going to say x halves equals that pi 6, right? Plus k pi. Because remember, this is my s value, right? Now let's solve for it. To undo the fraction, I need to multiply each part by 2. So I got x is equal to pi thirds plus 2k pi. Okay, so let's finish this one up. So let's find one more value. Let's say when k is equal to 0. So when we got one value, we got this here, right? We got one value of pi 6. What if I said, let's let k equal 0 and I plug it into this equation, then my next value would be pi thirds. So I have pi thirds, comma, pi 6. And my apologies that it erased the whole screen. I hope that you can rewind this video and go back to the work. I will write the actual formula here. Okay, and the work, my apologies. Again, just go back and rewind it just a little bit and write it down. All right, let's go to our next example. Our next example says we have a center fielder finds a ground ball and attempts to make a 240-foot throw to home plate. Given that the center fielder commonly makes long throws at 75 miles an hour, find the 2 possible angles at which he can throw the ball to his home plates. Find the time saved by choosing the smaller angle. So we're going to find the 2 possible angles. We're going to use the equation of our velocity squared, and I'm going to put a 0 here as a subscript because it's going to be my initial velocity. And then we're going to say sine is equal to 2 theta, and it's equal to 32d. This is a given formula, okay? Now let's solve for it. Well, if I take that velocity, initial velocity, and it's 75 miles in 1 hour, we know that we have 1 hour, there is 3,600 seconds, right? We also know that there's 5,280 feet in 1 mile. So I can go through here and say, oh, look, the mile reduced, the hour reduced, and I'm left with feet per second. That's what we want for velocity. So now I have 75. So take that 75 times it to 5280. And then we're going to divide it by 3600, and we get 110 feet per second. Okay. Now, if I got 110 feet per second, well, let's just make another one. It says that we have a distance of 240 feet here. It was given to us. The 75 was given to us. The rest is what we know. So now let's finish up. So I'm going to take this velocity. Whoops, I meant to write it as a, there we go. It's not a very good V. My apologies. It should be a little bit of a cursive V. But since my computer is acting up today, I don't want to try to erase that. Just, yeah, try to make it look like a V. Okay. I got that equal to sine 2 theta is equal to 32d. So now what I'm going to do is my velocity is what, 110 feet per second. And we don't need this equal sign anymore because it's going to be multiplied. And it is a notation error. Let's erase that equal sign. My apologies, guys. All right. And we're going to put in the place of D the 240 feet. All right. So far, so good. What I want to do is divide by this 110 feet per second to both sides. So now I have sine of 2 theta is equal to the 32 times 240. The feet's reduced, and it's going to leave me with seconds. The notation of it. And don't forget, this was squared. The velocity was squared. So we're squaring that 110. I'm going to try to scroll down, so please write down all this information. Pause it if you have to, just in case my screen, my computer decides to erase it all. All right. Now, I got 32 times that 240 divided by 110 squared. Let's just double check my math before I write it down. And I'm going to round to the nearest 5 decimal places, okay? Which is 10 thousandths. So 0.63471 is what I got. Now I'm going to say, okay, let's find the inverse of this. So that means I got 2 theta is equal to sine inverse of the 0.63471. And then I'm going to get an approximation, and we are working in degrees. So make sure your calculator is in degrees mode. All right, now let's take our sine inverse of that 0.63471 and round to the nearest thousandths, which is 3 decimal places. And this is what I got. All right, now that I have this, I'm going to take my 2 theta. I'm going to set it equal to my what I'm going to get. I got the 39.398 degrees. I'm going to divide by this 2 on each side. Now I have theta is equal to the 19.7 degrees. So that's one of my answers. So I got my 110 feet per second. I got the time. Now I'm going to have 2 angles here. So 19.7 is one of my answers. And then let's take that 2 theta and, oh, I was getting ready to divide. Give me a second. It's going to be equal to 180 degrees minus that 39.398 degrees. So, and then we're going to divide by 2. So now I have theta is equal to, and let me just double check my numbers, 180 minus 39.398 is 140.602. I'm going to divide by 2, and I get 70 0.3. I'm rounding to the tenths on my final answers. You don't want to round very much too soon on the middle work. You want to wait until round on the final answer. Okay, so we have our time and we have our two angles.